Okay, so this is day 2, lesson 2. It's going to be a 2-day deal. We'll do a worksheet today, which I passed up the wrong one the first hour. So lesson learned. This is September the 4th, correct? Is that right? Right. Okay, I gave you yesterday 7 parent functions, correct? You need to memorize those on how to graph them. All right, so this first one, you're going to need your graphing calculator to do today because we're going to go through. The other teachers use Desmos. I'm going to use this because you can use these on a graphing on an ACT test. All right, so I'm going to teach you how to use them. So this one here, your parent functions. This one here, which is a quadratic. Agreed? Squaring function. Remember that from yesterday? So I always do my parent function with x's. So 0, 0, 1, 1, 2 squared is 4, 3 squared is 9, and then I reflect it over the y-axis. So there's my parent function. Okay? Now, in your graphing calculator, turned on, of course, you see this button right here, y equals? Hit y equals, and you probably have some graphs in there already, correct? Right? So clear those out first. Okay, so go to y equals. Everybody see how to go to y equals? Top left. Okay, so type x. X is right below mode. Right below mode. And then you guys see the x squared key right here? Hit that. Now, go to zoom. Okay, I'll slow down here. Everybody got it? You have y equals x squared? I'll go real slow again. Everybody at y equals, right? Hit. The x key is below mode. And then the squared key is right there below x and -1. Okay? Now, hit the zoom key. Hit zoom. And that menu comes up. Just always start with zoom standard. Just hit 6 and it should give you the graph. I always like to start every graph zoom standard. Okay? Now, let me show you another thing it'll do. Hit the second key and hit graph, the top right-hand corner, and there's your table values. So you can get any table value you want. Does everybody see how to get to the table? Okay, so the keys you need today are the y equals, you need the graph, you need the second graph, okay? Those are the 3 that you're going to use, okay? Now go to y equals. Now let's put in the next one, which is x squared plus 3, and see what it does. So arrow down to y2, and then now we're going to go x again, squared, and then hit plus 3. Okay? And hit graph, top right-hand corner. And what do you notice that happened? What did it do to the graph? It shifted up how many units? Look at how many units? 3. Does everybody agree with me? It went up 3 units. It didn't change the shape at all, did it? Okay, so then just take all these points and count up 1, 2, 3. 1, 2, 3. 1, 2, 3. That one's off the page. 1, 2, 3. 1, 2, 3. Okay? So draw your graph. Okay? Now, go back to y equals. Now let's do x squared minus 4. So arrow down to x squared. So hit below mode is x. And then go to x squared, which is right here. And then hit minus 4 and hit graph. And what's it do to the graph? Shifts it where? down how many? 4. Okay? Just making sense? So then you're going to take your parent function, all those points, and go down 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There's that one. Okay? Just making sense. All right, now let's go to square root function. And you guys remember the table values I have you use for a quadratic, like for any quadratic. The T-chart I gave you yesterday for y equals x squared, like -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. Does everybody remember that from yesterday? Squaring function is what it is, okay? Now, the one over here, here's your parent function, which is the square root, correct? So the T-chart I gave you yesterday for the parent function, y equals the square root of x is 0, 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Probably not going to use 16, but I'll put it in there anyway. Correct? And you cannot take the square root of a negative number in a real number system. So here's your parent function. 0, 0, 1, 1, 4, 2, 9, 3. And I use x as when I'm dealing with my parent function. Okay? So let's do those now. Okay, so go to y equals, let's clear out the quadratics. Clear out the quadratics. So the first one was a parent function. So let me show you how to get the square root function. So hit the second key, the blue key, and then you see the x squared right here, and then hit x. Okay, now let's just do them all at once. Let's do this one here in blue, and then we'll do this one here in green. Okay, so the next one I'm going to hit second square root x, and make sure you arrow out of it so it's out of the radical. So you want to right arrow out of it, and then plus 2. And if you hit graph, what's it do to the graph? What did it do to it? Did it shift it up 2? Yep. So it should shift it up 2. So I'm going to take all those points and count up 2. 1, 2. 1, 2. 1, 2. 1, 2. So it should look like that, correct? The next one, hit the blue key, square root, x, put the x in, but you got to arrow out of it to get out of the radical, correct? And then -5, and hit graph. And what's it do to the graph? Shifts it where? Down 5, doesn't it? Correct? Are you able to plug this in? Miles, you able to plug this in your calculator? Landon, are you able to plug in your calculator? Okay. So I'm going to take all these points and go down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Make sure you start at the parent function, right? 1, 2, 3, 4, 5. There it is. Does that make sense? Okay, so what does, this is called a vertical shift, and this tells it to go, that K out here, up by K. This one here is down K. So vertical shift. Okay, vertical shift. Okay. Didn't do anything to the shape, did it? It just shifted it up or down. Okay, let's go to the next one. Okay, I'm going to do this one here. How many absolute value function, correct? Agreed? So take your calculator, and we got to clear out all those things we've already put in there. Agreed? So go to math, arrow over to number. And everybody see ABS. Hit number 1 and then put the X in there. You don't have to hit Zoom Standard or anything because it's set for Zoom Standard until you change it. Does that make sense? So hit graph and it should give you a Y-shaped looking graph, correct? Agreed? So the values you should have gotten that I gave you yesterday, your T-chart, for -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3, correct? And I could keep going if I wanted to. But when you take the absolute value of a number, it makes it positive, doesn't it? Okay? So we've got this right here. Again, I use axis for the parent function. Everything starts with the parent function. Okay? Okay, now, let's do the x plus 1. So, arrow down, hit math, arrow over to number 1, and then we're going to hit the x, which is below mode, plus 1, and make sure you right arrow out of that absolute value, and then hit graph. So what did it do to the graph? It shifted it left 1, didn't it? Kids, whenever it's inside of parentheses or inside an absolute value, I call it an imposter. You see plus 1, you think it's going to go right 1, don't you? But in reality, it went which way? Left 1. That's why I call it imposter. Okay? You guys know people that are imposters, right? There's something that they're not, right? Okay, so let's graph that one there. So I'm going to shift everything left 1. Take all those points, 1. So I'm going to shift everything left 1. Okay? Now let's do the next one. X minus 1. Whoops, I want to do that one in green. My bad. This one in green. Okay, so go back to your calculator. Go down to Y3. Hit math. Arrow over to absolute value. And then you're going to hit X minus 3 and hit graph. And it should shift it right 3. Does it do that? Did it shift it? Was it an imposter? Did it shift it right 3? You got to make sure you right arrow out of it. Does everybody get that or not? Need help? Okay, so then I'm going to take now my parent function. I'm going to shift it right 3. 1, 2, 3. There you go. Okay, does that make sense? Okay. All right, let's see if we remember the cubic. So this one here was the absolute value function, wasn't it? This one here is a cubic function. So if you remember, I gave you these values for your T-chart. -3, -27, -2, -8, -1, -1, 0, 0, 1, 1, 2, 8, 3, 27. Probably not going to use 3 and 27, are you? Correct? So let's graph that baby. So go to your calculator, clear those out, and I'm going to type X. Whoops, I got to clear this one out. Okay. Hi, Cole. Okay. Now, we need to get an exponent there, don't we? Correct? So do you see the clear key? Hit that little key below the clear key is an exponent. And then inside there, you want 3. Everybody see I got the exponent, the little upside down V. And hit graph. And it should look like that, correct? So 0, 0, 1, 1, 2, 8, correct? -1, -1, -2, -8. So it should look like this. All right. Now, the next one is this one here, which is x minus 2. So I'm thinking it's going to be shifted right too because it's an imposter, right? So go to y equals, arrow down, parentheses, correct? Then x minus 2, close parentheses, to the power of 3. I'll let you see. Can everybody get that right there? Does everybody have that? Hit graph and see if it shifts it right 2 units. Does it? Yep. So take all your points 1, 2, 1, 2, 1, 2. From your parent function, 1, 2, 1, 2. Okay, now go to the next one. Go arrow down to parentheses, x plus 3 quantities to the 3rd power. And everybody get that? Mm-hmm. Is everybody getting this in your calculator? Because I want to make sure you can do this. Hit graph. Get it shifted left 3. So what's the little thing I've told you? When it's inside a parenthesis or an absolute value, it's an imposter. If it says plus 3, it's not going to go right 3. It's going to go which way? Left. Okay? So let's do that one now. We'll do that one in green. So take from my parent function, I'm going to go left 3. 1, 2, 3. Okay, that makes sense. So now, turn the page. So what did we learn? We should have learned that this is a horizontal shift. When this is x plus h, we're going to go left h units, correct? And it's x minus h, you're going to go right h units. It's always an imposter, isn't it? Correct? Okay. Let's review the square root function. Let's do a little T-chart here. Now we're going to start talking about reflecting. Reflecting over the y-axis, reflecting over the x-axis. Okay? Am I going too fast or no? If I go too fast, say slow down, do it. Because I do this all day and I get to going too fast sometimes. So if I do, just because it doesn't matter that I know how to do it. It matters that you know how to do it. Okay? Because I can do this stuff in my sleep. All right? So you guys remember from the T-chart that the square root function is 0, 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, 16 is 4. Probably not going to use 16 and 4, but I did it anyway. So 0, 0, 1, 1, 4, 2, 9, 3. We cannot take the square root of a negative number in the real number system, can we? Okay? So in your calculator, let's clear all those other graphs out. Clear, clear, clear. Okay. Now we got to get a square root. So hit the blue key, the second key, and the square root is where we were hitting x squared. And then type in x for that, and then hit graph, and it should give you the graph. Did everybody get that? Did I show you how to get the ordered pairs? Look, hit the blue key and hit graph, and there's your ordered pairs. And notice where x is negative, what does it say for the y's? Error, because you can't take the square root of a negative number. That's why it says that. Does that make sense? Okay? Yes or no? Yeah. And you can down arrow and get some more points, okay? Square root of 4 is 2. Square root of 9 is 3, and so forth, correct? Okay. All right, now let's do the next one in blue. Notice the negatives on the outside. Everybody listen to me. Everything on the outside deals with the y. Everything on the inside deals with the x. So when I'm on the outside, that negative, I negate all the y's, but I actually reflect it across the x-axis. That makes sense? The negative on the inside, I negate the x's, but that reflects it over the what? The y. Okay? So let's see what happens. I said since this is negative, I'm going to negate all the y's, which means it's going to reflect over the x, right? Well, let's see if that works. So go hit the opposite key. Remember the opposite key? Don't use subtraction, use the opposite key right here. Okay? Then hit the second key, square root of x, and hit graph and see if it reflects it across the x-axis. Does it? It does, doesn't it? And when it says I reflect it across the x-axis, that means if I folded it across the x-axis, that it would lay right on top of each other and you'd only see one graph. Does that make sense? Okay, so it's reflected. So this one here, you're just gonna, that one's gonna stay the same. So there's my reflection over the, even though the negative's on the outside, I negate the y, it actually reflects it, even though I negate the y, it reflects it across the x, doesn't it? Now let's do the next one. Okay, so go into, hit the second key and put the square root in there. And then now we're going to do this one here. Okay, this one here, put the opposite key. Don't use subtraction and hit X and then right arrow out of it, get out of it, and then hit graph, and it should reflect it across the y-axis. Okay? Negatives on the outside, I negate the y, but it reflects across the x. Negatives on the inside deals with the x, but reflects over the y. Does that make sense? That used to confuse me when I was your age. It don't make sense. When you negate the y, it reflects across the x. Not everything's easy, right? So let's do this one here. We'll do it in green. Here, go here. And Donnie, wake up. Do this one in green. And there we go. Okay, let's do the next one. Does everybody remember this is an exponential? This one here was a square root. And you're just going to have to memorize these. I mean, you have to memorize the parent functions. Okay? You're just going to have to do it. There's no other way. And then remember, this is a power function, correct? Or, excuse me, exponential. I call it power sometimes. Exponential function. And we're using this right here, correct? We're using an example of one. There's a whole bunch of them, but we're going to use the one with 2 to the x, okay? All right, so go to your calculator, and let's clear these out. And put in 2. Now, you guys know how to find the exponent. Right below clear, correct? So hit exponent, and then put x in there, and then hit graph, and it should look like that. Okay, so did everybody get that? That's a growth problem. So I think that what I used yesterday for this one is my T-chart. I went -3, which is 1/8, -2, which is 1/4, -1, which is 1/2. 0 is 1. Anything to the 0 power is 1, right? 2 to the first is 2. 2 squared is 4. 2 cubed is 8. Correct? So those were the parent function values I gave you. Agreed? Let's see if those values are in your table. -3, let's see what we get here. -3, what do they get? 0.125. Is 0.125 equal to 1/8? Huh? It is. -2, 1/4. Is that 0.25? Yep. -1, is it 1/2? 0, do I get 1? There you go. All right, so let's graph this bird. So we got 0, 1, 1, 2, 2, 4, 3, 8, -1, 1/2, -2, 1/4. So it's getting real close to the x-axis, which you have an asymptote there. Okay, now let's do the next one. Okay, the negative's on the outside, correct? So what's going to happen here is it's going to reflect it across the x-axis. Let's see if that happens. So you have to use the opposite key, then type 2, power, x, hit graph. Does it reflect it across the x-axis? Does it? You bet you it does. So let's do this one in green. So here, here. There you go. Okay, let's do the next one. Okay. So we have 2 to the power of opposite of x. And let's see what we get. Now we're reflecting across the y-axis, aren't we? Agreed? So there it is. Okay, is everybody able to put in your calculator okay? You doing okay? So, reflections. When the negative is on the outside, we reflect across the x-axis. Okay? When the negative is on the inside, we negate the x, but we reflect across the y-axis. Reflect across the y-axis. Notice we haven't done anything with the shape yet, have we? That's what we're doing next. And we'll be done for the day. Okay, translations, which is what we've done, and reflections, which we've just done, only change the position and location of the graph. The general size and shape of the graph is unchanged. Now we're going to do that. Example 4, let me give you the parent function here, correct? This is an absolute value function, isn't it? So if you remember the T-chart, -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3, correct? Take the absolute value of any number, you get a positive, right? So it should be here, 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 here. I'm going to use X's because that tells me that's my parent function. Now, this one green. So go to your graphing calculator, and we got to clear out those graphs. Okay, so hit math, arrow over to number 1, put in X, and there's your parent function right there. Correct? Should be a V-shaped graph. Did you get that? Math, arrow over to number, and then number 1. That's the parent. Now let's do y equals, arrow down, 3, then hit math, absolute value, X, hit graph. What's it do to it? Multiply. It gets skinnier, doesn't it? That's called a vertical stretch. Makes sense? It gets skinnier, doesn't it? Goes up quicker. So you're going to multiply all the y's by 3. That's what you're going to do. Did everybody get that? It's skinnier. We had a guy in high school, his nickname was Stretch Cunningham. Why? Because he was about 6'7" and he weighed about, he could run around in the shower and never get wet. He was so skinny. He didn't even cast a shadow. So we called him Stretch Cunningham. His name was Cunningham. Okay? Things you remember, right? Maybe you'll remember you'll remember Stretch Cunningham. You'll think a stretch, it gets skinnier, it's a stretch, right? Okay. All right. So let's graph that one. So I'm going to multiply all my y's by 3. So this was 1, 1, so I'm going to go 1, 1, 2, 3. I'm going to go up 1, 2, 3 more, aren't I? 1, 2, 3 more. Agreed? Wait, 1, 2, whoops. 1, 2, 1, 2, 3. I screwed up. I didn't start at the vertex, my fault. So 1, 2, 3. 1, 2, 3. There it is. Hold it, guys. I'm losing it here. Yeah, you start at 0, so then I go up 1, 2. My vertex doesn't change because I didn't shift it. So I'm going to go up from over here. I'm going to go up 1, 2, 3 there. There we go. So from your vertex, go up 1, 2, 3 to the right 1. Sorry about that. Up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1. So there's the right side. Sorry about that, kids. Correct? This number out in front is like the slope. So you go up 3 to the right 1. Okay? And then on the other side, you're going to go up 1, 2, 3 to the left 1. Up 1, 2, 3 to the left 1. Up 1, 2, 3 to the left 1. so it gets skinnier. So let's do the next one. 1 divided by 3. Hit. What? Do what now? Start the vertex, go up 3, right 1, up 3, right 1, up 3, right 1. And on the left side, go up 3, left 1, right? What? Then you connect them, right? Correct? Does that make sense? Do what now? They should, yeah. Does it? Correct? Because we didn't do any shifting, did we? Agreed? All right, now, 1/3 math, number, absolute value, x, hit graph, and it gets wider, doesn't it? Correct? It gets wider. So what you do here is your slope is up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Up 1, left 3. Up 1, left 3. Okay. Make sense?
How do you make a third?
Do what?
1/3.
Get 1 divided by 3. Okay? All right. Everybody get that one? Okay, let's do a line. This is linear, right? This one here was an absolute value function. Now let's do these other ones. So if I put in, let's clear this thing out. Clear, clear, clear. You should remember from a line, the T-chart, y equals x is my parent function, -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 4, 3, 3, correct? All right, it's a line. So it looks like that. Linear. Agreed? So we go to y equals x. You guys stay awake? You guys get your calculator out? Follow along? So I type x and I should get a line, correct? Do I get a line there? Huh? Y equals x. Now let's do y equals 4x. So come down, 4x. Now my slope is 4 over 1, isn't it? So it stretches it. It goes up quicker, doesn't it? Okay? So this one here, 1, 2, 3, 4 up 1. 1, 2, 3, 4 up 1. Down 1, 2, 3, 4, left 1. Down 1, 2, 3, 4, left 1. And draw my line. So it looks like that. The next one we'll do in blue. Three divided by 4 x. Hit graph. This one here doesn't go up as quick, does it? The slope is 3/4. So up 1, 2, 3 over 1, 2, 3, 4. Up 1, 2, 3 over 1, 2, 3, 4. Down 1, 2, 3, left 1, 2, 3, 4. Down 1, 2, 3, left 1, 2, 3, 4. So it looks like this. Okay? So, what did we learn here that happens? If in a vertical stretch, if it is a vertical stretch, then the absolute value of A is greater than 1. If it's a vertical compression, then the absolute value of A is between 0 and 1. Absolute value of A, it means it's positive. So stretch, compression, or shrink. Okay, so look at example 5. First place, can anybody give me the parent function for this one? Everybody agree with me the parent function is a quadratic for this one? Agreed? Okay. So everybody agree with me this one here would be right 2 down 3. How'd I get right? Okay, so we'll finish these up tomorrow. Let me give you a worksheet that you need to take with you. And I'll finish the notes up tomorrow. Nice job, Dave.